How's it going, everyone? In today's video, we're going to learn about how to create generators in Python. And I'm also going to be showing you something else that's pretty important, how to type them. And you might be asking, why is knowing how to type a generator important? Well, on top of making your code more type safe, the generator type gives us a lot of context regarding what we can do with it. A lot of tutorials might only show you how to generate values, but the type annotation suggests we can do much more than just generate values. We can also send values to a generator and return values from it. Now, before we dive into today's video, I'd just like to thank Zed for sponsoring the channel. Zed is a lightning-fast code editor written in Rust, and I've been using it a lot lately. If you feel like trying out Zed, I've left a link in the description box down below where you can download it for free. Anyway, let's get back to the video. Starting off with a basic example of a generator, which could look like this. First, we create a regular function, and this will generate numbers. And as an argument, we can supply an amount, which will be the amount of numbers we want to generate. And this will return a generator, which will yield values of type integer. And this function will generate numbers on command. Nothing will be loaded into memory until we explicitly request it. So next, we're going to loop for I in range amount. And instead of returning a value, we're going to use a new keyword called yield. And the only difference between a generator and a regular function is that in a generator, we use the yield keyword to yield a value, which is essentially the same thing as returning a value. But again, a generator only loads data upon request, which is useful when you have millions or even billions of values that you don't want to load into memory all at once. To demonstrate what I mean, we're going to create a number generator. So here I'm instantiating the number generator with a value of 10 to the power of 1 million. And just to show you what this number looks like, I'm going to print it to the console. Or it looks like I can't because it exceeds the limit. So maybe we can make this a bit smaller, such as 10 to the power of 1000. And when we run this, we should get this huge number back. So now we've created a generator that contains a range of numbers all the way up to this massive number. And instead of loading every single one of these numbers leading up to that giant number into memory immediately, we can load a single number into memory at a time. To do this, we use the built-in next function, and we call it directly on the generator. But to see the result, we're going to have to print it. So let's print the next three numbers. And when we run this, what we should get as an output is 0, 1, and 2. We can also load data into memory via a for loop or list comprehension. For example, maybe we want to generate more numbers. So here I'm going to call next on numbers for the next 10 numbers. And when we print more numbers, it will generate 10 more numbers, picking up from where we left off. Note that once you retrieve a value from a generator, it disappears from that generator. That means that we will only be able to retrieve the next values in the generator from that point forward. Which means if we were to print the next number once again, the generator will continue from 13, as you can see here. But what happens when you run out of values in a generator? Let's create another generator and see. So here we have a generator that contains 3 values, and we can use next 3 times, and this program will function properly. But the 4th time we try to call next, we will run into a stop iteration. And this happens because we ran out of values to yield. What's cool about generators is that we can deal with data that's possibly infinite. For example, here we have a function called powers of 2, and what it does is calculate the powers of 2 for all of eternity, or at least until your computer runs out of memory. As you can see, we have a while true loop that never ends. It continuously yields n times 2 and updates n. So, to test it out, we will generate 10 numbers. And to do that, we first need to instantiate the generator. Then we can use a list comprehension and call it 10 times. Now, when we run this, what we should get as an output is 2, 4, 8, 16, 32, and so on. And then we can even generate more numbers after that. And it will continue from where we left off. And once again, the generator only does this when we ask it to. We only get the data back when we request it, which is much more memory efficient than loading all of this into memory immediately. Moving on, I want to cover the next part of generators, the return type. And for this example, we will generate random numbers and append them to a list that keeps track of them. Once we run out of values to generate, we will return a string that contains all the values we generated until now. Notice how I specify that I'm returning a string here. I am yielding integers, but I'm returning a string. So as soon as we run out of values to yield, we'll be able to return the final value. Next, we need to start the generator. So we're going to create some numbers. Then we're going to print the next 4 numbers. And when we run this, we're going to get 3 random numbers back and the stop iteration, which contains the value finished generating with the 3 values we generated. So that value is returned as part of the error. If you want to use that value, you're going to have to use a try and except block to grab it from the arguments of the error. As you can see down here, I'm grabbing the arguments at the index of 0. And when I run this, I end up with the actual value. Now, the last thing I want to talk about today is the send type, because on top of retrieving values from a generator, we can also send values into a generator to keep it in motion. To explain how it works, I'm going to create one more function. And this time, I'm going to specify the send type. So I want to be able to send lists of type integer into this generator. Then I'm going to create a while true loop, and to retrieve a value, we need to use the yield keyword here. But this time we're using it to retrieve a value, and we're going to assign whatever we retrieve to this variable. Then we're going to check whether we received an input, and if we did, we're going to continue with our generator. And for this silly example, we're just going to multiply the number by 2. Next, we're going to create the generator, and the first step is to start it. This will return none, because there's nothing in the generator. We are just starting it here. As you can see, when we run this, we end up with none. But below that, we're going to send some values to the generator using the built-in send method. And the sent values will be inserted here. Note that as soon as you send a value, it uses it immediately, meaning we get the output immediately, which is the result of 1 times 2. Then we can retrieve more values by calling next. We already retrieved the first value, so we only have 2 more which we can retrieve. But here I'm calling next 3 times. So let's see what happens when I do that. As an output, we get 4, 6, and then none once again, because there are no more values to yield. We need to send more values to the generator. So once again, let's do that. Let's send the values 10, 20, and 30 into the generator. And then let's grab those values by calling next 2 more times. Now, when we run this, what we should end up with is 20, 40, and 60. We got 20 back when we sent the values into the generator. Then we got 40 and 60 back the next 2 times we called next on the generator. And at this point, you might be wondering, when will we encounter stop iteration? Well, with this function, we will never encounter it. So if you want to stop it, you'll have to use the built-in close method. So right below number 8, we're going to close the generator. And what you'll notice is that as soon as we close the generator, we will no longer be able to retrieve values from it. And just like that, we learned how to yield values, send values, and even return values from a generator. The type annotation might look a bit complex at first, but as soon as you understand that this is the yield type, this is the send type, and that this is the return type, all of this becomes quite simple to understand. And in a future video, I'd like to dive into some more practical examples, because all of the examples I showed you today were simplified, and I'm sure you're dying to see some real use cases for all of the features I showed you today. But I'd like to hear your thoughts on generators and whether you had any interesting experiences with them. Do let me know in the comment section down below. But otherwise, with all that being said, as always, thanks for watching, and I'll see you in the next video.